opposed in A1 and A2 and 0, like in the top. What? So someone said this and that, and then the other. Okay. That's what I was understanding. You know, understand we're always options. Right. Thank you.
I'm not going to bang my head off. This is a lot of fruit.
Yeah. I think mine should go different than some people on that. Like, sit and do it someone. I think Robert is doing a lot of it. Trying to remember.
I forgot my glasses and my head is absolutely pounded. My head is pounded.
I really am sorry. I get migraines. I do. Sorry.
I don't even know if I do it right, to be honest with you. How did you do 7? Because I
Did my any was 1.
Mhm.
And it was 1 first. I put all those together so I can look at it. And I picked a piece. I picked the Nichols Bay, 2K is less than to the K. And to make it match the equation, the last one, I multiplied both sides by 2. I got 4K is less than or equal to 2K plus 1 all power. Because we have 2 raised to K is 2 K.
I feel like we've done something like that somewhere.
Better.
Okay. Okay, now I have that. Which is 2 things that you make it hard is 2 it's 2 times 2. Okay. When you break it apart.
Right.
So you didn't do anything with the time. So that's why I got 2. And then you have, okay, I see what you do. Right? You want to have -2. -2 plus 2.
I pulled 2 out all the way. Here's 2 K plus 1.
Okay.
Yeah.
Plus 2. Well, you pull it
Pull it out here and pull it.
so you can't plus 1.
So you're still pulling it 2 out. So that's why I didn't write mine here. You never like this.
No, it is. Yeah, I know it is, but it just, I sometimes,
But he showed you that. Okay.
yeah,
Yeah, I get it.
I made it harder than it really needed to be.
Yeah, I do that a lot. So each individual piece, though, is in the subset, right? Like,
Yeah.
I have them right.
Here's the notes. Yeah. It's this right here.
Parentheses and brackets. That's all.
Yeah.
Okay, okay.
This right here is just nothing.
I had to see.
Did you still want my email? Thank you. Okay, so
how did you guys look? Let's look at number 12 on the homework.
we haven't finished number 12. So I don't know.
Number 12 on the practice stuff?
Because she was going over. Oh, no, I don't even look.
That's why I said
What chapter?
5.2.
We're all says A, B, and C.
If A is a subset of B, and A and C.
Yeah, that's something that we're getting ready to do, that she was getting ready to go over. So we get it.
Oh, sure.
Yeah, because look, she was getting ready, remember she was getting ready to,
Yeah,
and she got it all,
I went to that.
and we got cut off.
Yeah, that's
Okay.
very simple. Right, she started.
We got cut off, so.
I haven't been feeling it for like 2 weeks now, but I feel sick. But like sick enough to where I might have to take her to the doctor. No, I looked at the syllabus and it was just like bring your lessons. Until I go over them. He's already like, yeah. Like
How did you do that?
okay, so
I got,
Did you do the M and the N?
I did the M. I did it.
I
How much
do.
I probably should have an M.
I was gonna.
I did
She's
my anything one.
How did you? I got the.
Not too bad.
I did it the same way I did this. And then I tried to take the part I'm going to finish.
Because if I would have for the
I know, that's where it came out.
does that mean we have
The
to
first part. And so I have
That's what I was
to
wondering.
papers.
Should look more. But then this one.
Once we get into that, there was one. It was just.
And then
Yeah. That's why I said I'm not sure to do it exactly right.
I think I did it right.
And the bottom, it does seem weird. I still got to do this, but I'm not sure that I'm necessarily correct.
All I know is that.
Change, like.
Well, it's A plus.
So I have to keep this one.
I got that.
It was just like.
Yeah, I don't know how to do it.
Not even really. Because I got that's 2.
So, 3 to the 1.
I really do appreciate this.
Oh, wait.
Yeah, they are very good.
3 minus 1 is 2.
Honestly, I'm not sure.
2 is where we went.
I really think that. I did
So
it.
you didn't pay her, just. Did you pay up or did you pay this up?
A lot. But I go back. The whole problem, yeah.
Is it visible much?
So, that's not true.
Yeah, she said.
I said it was equals to.
How do you roll to the
That's what she's going over. Yeah.
So I did it.
I looked at these.
But then when I looked at that, I realized that when you substitute A plus 1, when you were just talking about all the stuff and not trying to M, you can set it up that way. So then that 2M is equal to the same 2M.
Here's the definition of
Okay, so you just have
X belongs to A or where X belongs to B.
for X.
That's what that proves it.
Does that make sense?
Three.
There's so much I didn't have.
3.
It was so,
Three. Okay.
But he and the this is
Yeah. It would be
like sending.
So I did it, and the other two in there. Obviously, 360. Is that right?
Oh, I did do a little bit. Two.
I was gonna say, I know, I didn't do it on my exact same dress.
Yes.
Right, because that's right. This one belongs. Yes. This one.
So it's that.
because I divided over here because isn't it what you want to just put little add here.
Right? Is that what? Did you do?
E,
But I didn't.
I might be wrong, but I
I didn't
think
do
it's
that.
E is if it's exactly like that.
Got it?
So you
I don't
take
think that is a subset because it's not in brackets. That would be, that's right.
Alright. And then this one? So this one is exactly like.
Yeah, that's what I
Oh,
thought.
is myself.
That's,
Once you get over here, you can add it to here. Yeah.
Correct. That would be
Right?
subset.
Yeah, and pull two out.
Okay.
Out of the end.
you must get quarters cost too. Okay. Yeah. We have those.
And then it's
Actually, so
Are we doing good circle? Are we?
We are. No, we don't have it.
Did you listen to that? I really changed the word.
Oh, you didn't subtract?
that's not.
I liked it a lot.
Right?
Oh, you know what it is.
I don't know how. That's right. I don't know where.
I don't want you to go there. I know. Pretty much.
No, this is 2K and this is 2K.
Hey, wait till Wait, which is cool.
Yeah, it might-
So that starts in off.
I don't know, somebody's house, I think it was the president.
Yes, you're right.
Well, Eddie Jefferson was.
Wait, what was his name?
No,
Oh, I know,
I'm just,
sure, yeah.
I'm not saying you're wrong. I just,
General
Jefferson
Jefferson.
was a president, but I don't think he was from Ohio.
I didn't mean Jefferson, I'm not sure. Like the general Jefferson's house.
Is it cool?
We went into like the decorative art center and it was pretty cool. It was like a mansion, the house was. And
Was it haunted?
was
Weird.
No.
Is it like creepy out?
no, not really. But I guess like the upstairs is, but no one's allowed to go in. So that poor guy lady. She's like a retired teacher. She's about 30 years.
Hey, Megan.
Here.
Elsa.
It's like another story.
Elsa? Morgan.
Here.
Allison. Here. Katie.
Here.
Leah.
Here.
Catherine. Curtis.
here.
today I'm going to finish chapter 5, the proof problems of set theory, and I'm going to answer questions about practice exam. Okay, so on the practice exam, there is a question number. The last one, we did cross out number 13, number 14, and 15. So number 12, to prove the union of A and B is equal to B. So that is a equation of two sets that we need to prove. So I am going to go over the proof problems with you here again. Like I said, we got two types of proof questions. I asked you to do some homework questions of the first type. How do we prove one set is a subset of the other? We go by definition. If they say you have to use the element argument, then you cannot use any properties that have been proved in the textbook or in class. So you got to use the definition of subset. So the definition of subset, you memorize in a sentence, but when you write it down, you use symbols. It's not wrong to use sentences when you write down a proof. If you prefer words than symbols, you can, as long as you say it correctly. So when I memorize the definition, have you all memorized the definition of subset without looking at your notes for the textbook? Danielle? In this case, every element of X. Y. Yes, exactly. That's the definition. So you're going to memorize in words. But when you write it down, how do you write down every element? So I'm going to write down the sentence she said. Every element of X is also an element of Y. Now, start with the first word. Phrase, every element. How do you describe every element? By symbols. Use a letter, right? Usually we pick X to represent it, but because I have another, the set I have is also X, so that's why I changed it to A. But if you like the lowercase x, it's fine, whatever the letter you use. So I picked the A to represent every element. O of X. What's the symbol for O of X? Which means in X, right? Every element, well, instead of saying O, if you want to say in, every element in X, that's fine. So use the symbol belong to in X. You start with the element, every element, arbitrary element A in the set X. That's what I put. Every is, we use the symbol, every, okay? So for any, you can read it as every. Usually when we read this upside down A, we say for any element A in X. But if you want to say every element A in X is also an element in Y. So in Y, instead of using O, in corresponds to belong to symbol. An element, this element means the same element A. So when you translate that sentence into mathematical symbols, you're going to get this. Okay. All right, so that's the definition you have to use. In the homework, we didn't have two. I asked you to do two problems. I don't know if you had trouble doing that. Let's see. Number 5.2, part B, 12, right? Did I get number 12? Yes. Okay. So number 12 under 5.2. Did you have trouble writing a proof for number 12? Yes. Yes? Yes? Okay. What about number 9?
Yes.
Yep.
Yes. Okay. Do you know what to start with? So it's pretty much like a format that you have to use. Okay. You have to follow that format. So we did start with that. Do you remember what we start with? What is the first thing you would say when you ask me to do a question like that? For example, in number 12, you directly go to what they ask you to prove. So in number 12, what did they ask us to prove? ask us to prove. Prove what? What is a subset of the other? The intersection of A and C is a subset of B and C, right? So think about the definition we went over. What do you start with? Oh, yeah. So what do you start with? When you write what would you start with? What's the first thing you would say? There is a format that you always use when we talk about our element argument. So that definition that I just went over with you, remember what's the first thing you would say?
Is that when you were?
Say it again.
Is that when you were saying like every element of the intersection of A and C is an element of B union C?
Yes, I mean, yes, that's our final goal, yes. Let's look at the slide we talked about last time at the end of the class. So this is homework question number 12, 5.2, number 12. We did. So this is your final goal. What you just said is our final goal. Every element of A intersection with C is an element of B intersection C. But which means you are going to start from this goal. We realize that we have to start with what? We start with an element X from intersection of A and C. So that's what you're going to start with. Okay, so first of all, you need to know this is what you need to prove by definition. What do we need to prove? You need to prove every element of A and C is the element of B and C. Okay, is that right? Does everybody understand this part? Yes or no? Yes? Okay. So that is just repeating the definition, changing the word subset to a sentence. And how do you prove that? You start with an element of A and C. You show, usually we call it X. You show X or A. You show that X is also in B and C. Right? Okay, so that's what the format you're going to start with is, I can show you the problem I did in class, the format. So this is what I did in class, the example. I want to prove intersection of A and B is a subset of A. So that means I need to show every element of A and B is an element of A. I've changed this to sentences to help myself to remember the process. So when you start with, look, the first sentence you start with is always, let X be an element of A and B. Why did I know I should start with this? Because I need to prove every element of A and B. I call it X. X is the element of A and B. I need to prove this X is also in A, right? So that's why I start with element X from A and B. And my final goal is I try to show X is also in A. Okay? Is that clear? So, because our final goal is to show, let's look at the sentence I wrote down last time, and so this is what I want to show. I want to show every element X in A and C is also element in B and C. So you're going to start with this X from A and C. The first thing you write down is always this. So let X be an element of A and C. You can use sentences if you don't like the symbols. I'll always use symbols. But what is your last sentence will be? What's after you show all these arguments? This is the one you need to write down. And what would be your last sentence? X is very good. X is the element of B and C. So your last sentence would be, therefore, X is in B and C. And by this, so if you look at these two, combining these two sentences, what does this tell you? I picked the element X from A and C. I proved this element X is in B and C. What does this mean? Combining these two, what does this mean? Every element in A and C is also element of B and C, right? You see that? So that's why you always have this format. Okay? If you want to add another sentence, say, therefore, the intersection of A and C is a subset of the intersection of B and C, you can add another sentence. But this is the main part of the proof, the main body of the proof. Okay, is this clear? All right, so that part there, I leave it to you to finish. I'm going to give you another example, though, today. Maybe that example will help you to do this. So the example I didn't start with, I started it, but didn't finish. I write down the steps. So that's in the textbook. It's called the distributive law. So this is the problem I was going to prove. As you can see, it's much more complicated than the first example I did, and it's much more complicated than your homework question. So you have just A and C, B and C. What I have is A, B, C, 3, and it's very long on the left and right. Okay, so I did say there's another type of question you need to show two of them are equal. We also have those in the homework and also in the practice exam. So in order to prove two sets are equal, what do we have to show? Two steps. Which two steps? How do we show two sets are equal? Yes, that's right. So what James just said, they are subsets of each other. Pretty much, well, we can simply put two sets are a subset of each other, but when you really do it, you have to do two steps. So first, you got to do X is a subset of Y. And after that, you gotta prove Y is a subset of X. In both directions. X is a subset of Y, Y is a subset of X. I did explain that last time. Well, how do you prove X is a subset of Y? Type 1, which we went over, that format that I gave you. How do you prove Y is a subset of X? Type 1 again. So when you do type 2 question, when you prove two sets are equal, you are doing type 1 2 times. So if you know how to do type 1, you should be able to do type 2 because it's exactly the same thing. You just have to do 2 times. So this is the question I am going to do. So I want to prove these two sets are equal. Which two sets? It's a very complicated set. A union B intersection C. And the other set is also very complicated. A union B intersection A union C. So I want to prove these two big sets are equal to each other. By the definition, how do you prove two sets are equal? 2 steps. I'm going to show one is a subset of the other, and the other is also a subset of the first one. So that's why I have to break it down into 2 steps. A union B intersection C is a subset. Look at the symbol. It's not equal anymore. A subset of the right side. A union B intersection A union C. After I'm done that, I have to do another step showing the right-hand side set. A union B intersection A union C is a subset of the left-hand side. A union B and C. Okay. So when you look at your practice exam, there is a question similar to that, but you're trying to show, well, it's much easier. You're trying to show A union B is equal to B. Because I noticed this. Did I not switch? Huh? You can't. Oh, is that? Wait, what is that? Let me ask them. Hi. You know how to fix that?
Yeah, it's like,
Yeah, it's on there now.
Oh, it is?
Yeah.
Okay. Wait, that's still the, I'm trying to show the computer. It's not showing the computer. Oh, that's okay. I'll just write it down on the paper.
You're starting it might work. Right.
Okay. Well, anyway, so it has problems with this. Okay. So I'm just going to write down the question here. So on the practice exam, there is a question. If you look at the practice number 12, so the problem says you ask you to prove A union B equals C. Okay, so which means step 1 we have to show what? What do we have to show? Steps are equal. How do we show two sets are equal? They're subsets of each other, so there are two steps that you got to do. Which two steps? Step 1, you're going to show A union B, yes, is a subset. So you're going to change the equal sign to a subset symbol, a subset of B. And what else do we have to show?
D is a subset of A union B.
Yes, B is a subset of A union B. I already have them on the paper for you, because in the past, like I said, the students have trouble doing this, and they tend to forget two steps. So that's why I put it there for you. There are two steps that you got to do. So all you have to do is continue to finish the subset. How to show a set is a subset of the other, which goes back to what we talked about before, type 1. So both are the same process. All right, so I'm going to go back to my example. Again, it's very, very long. So let's take a look at this. So step 1, step 2 are similar to those two steps there. How do we show? So next thing is, how do you show A union B is a subset of B? Well, how do you show B is a subset of A union B? And that's what you need to do there. And you got to show every element of A union B is an element of B. And you got to show over here every element of B is an element of A union B. For my case, what do I need to show? So what is following the format that I gave you? This is always the format. You start with an element from the smaller set. Try to prove that element is the superset. So what do I need to do? What do I start with here? Let what? What do I start with? Let X be an element of which one? The first one. Always the one, the smaller one, the subset. And what would be my last sentence? I would have to say what? X is also in what? The one on the right side, right? So how do I do that? Let me put the last sentence here. I don't know if I have enough space. I may have to move this later, but I'm going to go ahead and put it there. So this is going to be the format you always have. Okay, when you do a proof in set theory, subset proof, you always start with the element from one of them. You're trying to prove X is in the other. Okay, so now, the rest of it, the proof here, you got to use the definition of intersection and a union. Either you can start from what we know, so this X comes from a union B intersection C. So what does this mean? By the definition of union, X is in a union. So what does that mean? what will follow from the definition? By the definition of union, what do I get? If X is from the union, X will be, remember the definition of a union? What does this U correspond to?
An element of A or an element of B.
Yes. Yes, very good. So whenever you see union, it's the same as English word or. All you have to do is to write it in words. So by the definition of union, X is in A. When I see this symbol union, and it means English word or X is in what? Yeah, B and C, right? Okay. Is this right? Yes? Okay, all I did is to change this symbol U to English word or, because that's the definition. Okay, so there are two cases. Maybe X is in A, maybe X is in the intersectional union. So I'm going to do two cases. I think for your homework, word practice exam, I don't think you need to do cases. I think even if you have to do cases, it's going to be very easy. So I'm going to do two cases here. X is in A, case 1. Case 2, X is in the intersection of B and C. For both cases, I'm going to show X is in that intersection of this. So if X is in A, well, always, whatever I'm going to write down, I'm actually looking at what I need to prove. Okay, so I'm going to write this down here, and I ask you if you understand this. Then X is in A union B. Do you understand why X is in A union B? Following from the case assumption, X is in A. If X is in A, that's the definition of union again. What is the definition of union? If X is in A or X is in B, then X is in the union, right? Well, what's the case assumption? It says X is in A. Well, if X is in A, then X is going to be in the union, right?
Yeah.
Make sense? Okay, so that's just definition. I'm going to write down something else. And X is also in A union C. That is from definition. That is also from the definition of union, because the definition of union says if X is in A or X is in C, then X is going to be in the union. Well, we do know X is in A. Under case 1, we know X is in A. If X is in A, X has to be in the union of A with any other set. Okay? But the question is, how did I know I should write down these two conclusions? How did you know that you should write down these two conclusions? But that's what I need to prove. Look, let's take a look. What is that? X is in A union B, right? And what is that upside down U mean? English word. And what's that? A is in the union of A union C. A is in the union of A and C. Look, see that? If you ask me, how did you know you should write these two down? Because I'm looking at what I need to prove. And I can prove that. So case 1 is very easy. If X is in A, then X is in the union of A and B, and X is also in the union of A and C. Well, if X is in the union of A and B and A and C, of course, X is in the intersection. That's the definition of intersection. So I changed the word, English word and to that symbol for and, which is called intersection. Is that clear? Okay. So the process I did here is by using the definition of union and the definition of intersection. So when you do that homework question, it's going to be the same way. All right, let's look at case 2, see if I can still get that proved. So under case 2, I know X is in the intersection of A and B. What conclusion will follow from here? If X is in the intersection, it means, the definition of intersection, it means where X is in what? the symbol to English word. What's the English word for that?
And
And. So can you change that? What does this mean? What does this mean? Change that to and.
X belongs to B and X belongs to C.
Very good. Does everybody understand this? That's the definition of intersection. If X is in an intersection, X is in both of them. X is in B and X is in C. Okay, what do you think I should write down next step in order to prove my goal here? So, what do I need? I need what? I need X is in A union B and X is in A union C. Again, this is the word and. That's what I need. But what I have so far is X in B, not A union B. Can I get X is in A union B from that? Can I get X is in A union B from that? Can we?
Yeah.
Yes. Again, it's the definition of union, right? Definition of union says if X is in one of them, then X is in the union. X is in one of them. Which one? This time it's in B. If X is in B, of course, X is going to be in the union of A or B. A and B, so union. Similarly, what conclusion will follow from that? If X is in C, then X will be in what?
A union C.
Yes, very good. Because that's what I need. A union C. If X is in one of them, X is in the second one, C, then X should be in the union. And that's exactly what I need. And if you change the word and to that symbol, that's what we have proved. Okay. So under both cases, I proved X is in the union, the intersection of these two unions. Okay, questions? So I'm done with the first step. Now let's look at the second step. Second step, we're trying to prove the other way around. So this time, what do I start with? What should I start with? Let X be an element from where? The left-hand side, the smaller one, always the smaller one. And what would be my last statement? Therefore, X is in what? Which one? The superset, right? A union B and C. So all I have to do is to found the arguments to prove that is true based on that. Okay. So again, writing down a proof, it's sort of like, if you're a detective, you have some evidence you collected. That's the evidence you collected, and that is something you need to prove. Either you prove somebody is the murderer or somebody is innocent. You just have to make the arguments between them. So how do I get to that from here? So when you do the proofs, a lot of times you look at what you know, the evidence you have, or the laws you have, and also you're looking at your goal. You're trying to prove somebody is innocent or somebody is the killer, and you try to make connections. So if I look at what I have, the evidence I collected, so X is in the intersection. By the definition of intersection, what do I get? The X is where? In which sets? Definition of intersection. A union B. That symbol, when you see that symbol, change it to English word. What's that?
And.
What is that? And. Okay, remember that. That's and. And what?
X belongs to A union C.
Very good. Okay, is everybody clear? That's the definition of intersection. When you really write it, you just have to write X twice and change that to English word and. Okay, so that's what I got now. Here is what I need to show. how do we, now let's take a second and look at our goal. How do I show X is in A union B intersection C? Well, it means this union, U means English word or, right? So if you can show X is in A or X is in that, you will be done, right? So you have to show one of those two cases. Either you can show me X is in A, or you can show me X is in B and C. Then you're going to be done with proving that X is in the union. Okay, but look at what we have. That's the evidence we collected. How can we tell whether X is in A or not? By looking at them. What does this mean? If you look at the first one we got, X is in A,
Or B.
when you see or in B, right? Does that guarantee X is in A?
No.
No, it does not. So that's why you won't be, it cannot guarantee X is in A. So we're going to do two cases again. Possibly, yes, X could be in A. So if X is in A, great. We're done. Okay, so if case one is very easy. If X is in A, well, then X is in the union of A with anything else. Doesn't matter how complicated that is. That follows from the definition. Again, what is the definition of union? If X is in one of them, right, the X should be in the union. Is X in one of them? Yes, X is in the first one, first set A, right? So X should be in the union. Is that right? Okay, so if X is in A, great, we already have the conclusion. X should be in the union of A with anything. Well, what if X is not in A? That is the difficult part. If X is not in A, where will be X? Now, go back to the evidence we collected. We do know X is in the union of A with B. Okay, and we also know X is not in A. What conclusion follows from that? Combining these two that I'm pointing at. Yes, correct? Does it make sense? Then X is in B. So these two, let me circle them. So that one you're looking at, and this is what we're looking at. Following from these two, we know X must be in B. Right? Because what do we know? What does this tell us? X is either in A or in B. It has to be in one of them. But we do also know X is not in A. If X is not in A, it only leaves us the other option. X has to be in B, right? Because X is in the union. If it's not in A, it has to be in B. Similarly, by looking at the second one and the case assumption, what conclusion follows from that?
X belongs to C.
Very good, right? And if X is in union, X has to be in one of them. If X is not in A, it has to be in C. Okay, combining these two, what do we get? What is this? Change the English word "and" to the symbol. So X is in what? X is in B, and X is also in C. What does that mean? B intersection C. Yes, that's right. If B is in both of them, so B is in B and in C. Okay, can we get that? What did we just prove? For the union, if you can prove X is in one of them, if X is in this, you're done. Or X is in that, you're done. X should be in the union. So under case one, X is in A. There's nothing to prove. Automatically, yes, X is going to be in the union of A with anything else. But case two, if X is in the intersection, then X is going to be, X is in this part. If X is in that part, if X is in one of them, the X has to be in the union. So you also get the same conclusion. Okay. So as you can see, everything I write down is pretty much changing words to symbols or symbols to back to words. And definition of union, definition of intersection. Okay. All right. Any question?
I have one.
Yes?
I guess kind of what I struggle with is like figuring out like how to determine what the cases are going to be, if that makes sense.
Yes.
Like how did you go? Like how did in step 1 you said like X is between A and then X is between B and C, and then how did you know how to say like if X wasn't in it?
Like in this case, how did I know X is in A and X is not in A, right?
Yeah,
Okay.
how did you know to like evaluate it for those cases?
Okay, yeah, that's a good question. So how did I know I should do these two cases?
Yes.
Because I'm looking at what I need to prove. So this is what I need to prove, right? I want to show X is in the union of these two. I just copied that from here. So let me write it down again. So this is what I need to prove. Prove X is in A union. Let me use a different color for that symbol. B intersection with C. And again, this U symbol union means or. Okay. So think about the definition of union. What does union mean? How do you show an element is in a union? This means if you can show, there are two cases. If you can show X is in A, then X has to be in the union. The definition of union says if X is in one of these, if it's this one or that one, X is going to be in the union. That's the definition. So yeah, that's why how I know. Okay, well, do I know X is in A? So that's what the question I'm asking myself. Do I know X is in A or not in A? So, well, I go back to what I have, sort of like the evidence I collected or the conclusion I have starting from what I started with. I found out, well, I cannot guarantee X is in A because by looking at this, the one I two conclusions that I circled, I look at that. He only tells me X is in A or X is in B. So when someone tells you X, I may come tomorrow, today or tomorrow, can you guarantee this person will come today? No, right? Or means, okay, one of those possibilities. I may come today, well, maybe today, but maybe I'm not come today, maybe tomorrow. So when you have union, you don't know for sure X is in A or not. Could be in A or not in A, maybe in B. So that's why I have to do two cases. If I know for sure X is in A, I don't have to do two cases. I'm done. But that's why, because looking at those, both of them, because that means or, I cannot guarantee X is in A. So that's why I decided to do two cases. If X is in A or X is not in A. Okay. If X is in A, it's going to be in the union because X is in the first one. Let's call this the first set. And this is the second set. Although the second set has another 2 in there, right? But you can think of intersection as one single set. The intersection is still a set. So if X is in the first one, then I'm done. X has to be in the union. So the first case, that's why the first case is so easy. All you have to do is write down the case assumption. X is in A. Well, if X is in A, X has to be in the union because it's in one of them, in the first one. But there is a possibility that X is not in A, just like when I say I may come today or tomorrow. I may not come today. If I don't come today, then I will come tomorrow. So X is not in A. If X is not in A, which means X is not in this one. If X is not in this one, then I have to show X is in the second one, right? If X is in the second one, the X has to be also in the union. So how do I show X is in this part right here? That's what I try to do, find these two. And how do I get X is in B? Because we know X is in either in A or B. If it's not in A, it has to be in B, right? Similarly, X is in the union of A or C. If it's not in A, then it has to be in C. So we got the conclusion X is not only in B, but also in C, which means X is in the intersection. And that is exactly the second part of the union. So, well, I proved case 1, X is in A, then it's going to be in the union. If it's not in A, then it has to be in here. If it's in here, it's also in the union. Okay? Make sense?
Yeah, thank you.
Okay. When we go back to look at step 1, I also did 2 cases. But these 2 cases, not because I look at what I need to prove, it's because of the conclusion that followed from the assumption, because that symbol means or, right? Or just means you're going to have two cases. Either X is in A, the first case, or X is in intersection, the second case. So that for the first step, the reason I got two cases because that's the two conclusion I got. I don't know which case is going to happen, so that's why I do two cases. But for step 2, the reason I did two cases because of what I need to prove. I need to prove it's either here or there. That's why I do two cases. All right. Hopefully this will help you do the practice exam and the homework question.
For the practice exam for number 12, so it has the subset notation for step 1, prove that A union B is a subset of B. When we change that to words, so after we say let X be an element of that whole thing, do we say that X is an element of A union B?
Mm-hmm.
And then where do we go from there?
So you're going to have to show, so in order to prove, so that's the first step, right? So you want to show, whenever you do subset, you start with an element from A union B, like what you said. So you pick an X from A union B. And what is your goal? You need to show what? Where X is.
That
Which
A
step?
union B equals C.
This is our final goal. They are equal. But how do you prove they are equal? You break it down into two steps. You're not going to show they are equal directly. You're just going to show one of these is a subset of the other.
Okay.
So each step will become a type 1 question. How do you prove one set is a subset of the other? So that's our type 1 question. And how do you, so this is type 1. How do you show a set is a subset of the other? So like I said, a type 2 is doing two type 1s, two problems, to do subset twice. So you got to do this once and do that again. How do you prove a subset? A set is a subset of the other. What was the definition of subset? Every element of A union B is also an element of B, right? That's the definition of subset. So whenever you see this symbol, you have to change it to the definition, which means every element of A union B is an element of B. But how do you use symbols to prove that? You always start with an element from A union B. And to prove what? What do we want to prove? That's like a given. You start with. You're given an element X from A union B. What do you need to prove? You want to prove X is in which set? X is in which set?
B.
In B, right? So all I did is to translate, use words, use symbols for words. So if you say, okay, I don't know what I start with, what I should end up with, first thing you want to do is to change this to English sentence. So if you have trouble understanding this, so what does this mean? What does this mean? What does this symbol mean? Subset, right? So it's like saying A union B is a subset of B. And next, you're going to change the subset to the definition. What does subset mean? What do you mean a set is a subset of the other? Every element of what?
A union B is an element of B.
Yes. Or I can just say it's also in B. Okay, is also in B. Or you can say it's an element. You can add an element in B. So that is the definition you have to memorize. What's the definition of subset? Give you a particular example. If you have 1, 2, 3, and you have another 1, 1, 2, 3, 4, and you say that is a subset of that, right? Because every element, the first element of this is in the second set. The second element is also in the second set. Third element is in the second set. Every element is in there. we call this a subset. That's an example to help you memorize the definition. But when you are given A and B, they could be anything. They may not be 1, 2, 3. They could be A, B, C. Well, they could be people or numbers or anything in there. So you cannot pick a specific numbers to do the proof. But the way you do it is keep using this definition. Okay, so if you memorize this definition, the next thing you do is to put it in the format, symbols. How do we use symbols for that part? How do you change this part of the sentence to symbols?
X.
Every becomes what? Every element becomes an X, right? Okay, so that's why I didn't use for any. If you say, can I say for any? Yes, it's fine. But usually I just say let. Okay, let X be an element over there. But if you want to use upside down A, that's also correct. So every element, it becomes a letter X. In, what's the symbol for in? Belong to, right? A unit B, A unit B. So pretty much where does this come from? It comes from the first part of the sentence, the definition. And now, what do you need to prove? You need to prove this element is also in B. What's the element? It's X, right? What's in? Belong to B. So what do we need to prove? This is what we start with. You start with X in A union B. You prove X is in B. You see that? Okay. So although I always say when you memorize the definition and use sentences, but when you write down the proof, you will change the sentence to symbols. Okay. So this is how I know that I should write down X is in A union B, and that's how I should know. I end up with X is in B. X is in B. Okay? So similarly, can you tell me what should I start with for step 2? What should I start with for step 2?
Let X belong to B subset A union B.
Oh,
Or
no. Just the, okay, so you want to show only this, okay? You're not showing the whole thing. These are 2 separate things. So that is a set. That's a set. And this tells us a relationship between them. So you're trying to show this is a part of that. How do you show this is part of that? Subset means part of it, contained in there, if you don't like the word subset. So this is a part of that. How do you show this is a part of that? You start with everything in here, something in here, and you try to show what? What do we try to show? X is in where?
X is an element of A union B.
Yes, that's right. All right. So
Will
this
we
is
have 2 cases for those examples, or is that just because the other one was longer?
Like this one, you will have 2 cases because what does this mean?
And, or, I mean.
Yes, whenever you see or, there will be 2 cases.
Gotcha.
For that one, there are no 2 cases. And these 2 cases will be very easy. So which 2 cases will we have for that? Following the
X.
definition of union. Go ahead.
X exists in A,
That will be a
Or
case
X.
1.
or X exists in B.
Yes, that will be your case 2.
Gotcha.
So 4 cases. Case 2 will be very easy. If X is in B, you're done. Okay, that's what you need to prove. That's your goal. Case 1, you have to say one more sentence. Well, if X is in A, how do you show X is also in B? Well, there's another condition given. What's given? Go back to look at the problem. It says A is a subset of B. What does that mean? If they tell you A is part of B, A is contained in B, what does that mean?
A exists in B.
Every definition, every element of A is an element in
Of
B,
B.
right? So for your case 1, you should be able to prove every element, this X is also in B. Because it's in A, then it should be in B. That's the definition of subset. Okay, you have more questions about this type of question? So on Wednesday, I am going to go over the practice exam. If you still have trouble, I can give you more examples of this. In the practice exam, there's another question called Venn diagram. I think I did not mention that in class, right? Venn diagram. If you had statistics, you may have learned this before. What's a Venn diagram? Okay, so Venn, a mathematician, he created this, so we call it Venn diagram. Let me give you an example. If you have A as A, B, C, B is equal to C, D, C and D, C, capital letter C is equal to maybe F and G and H. So when we draw a Venn diagram, you draw a circle. Well, it doesn't have to be exactly a circle. You just any closed curve. So I'm going to put this circle represents set A. I'm going to put ABC in there. So it includes three elements, three members, A, B, C. So there's an A, use a dot, there's a B, there's a C. You can put it any way you like. Sometimes you may have to rearrange your points there because look at the B. Also, the set B also includes this element C. So when you draw another circle to represent B, make sure you include C in there. So when I draw another circle C, that's B. To represent B. B has two elements. One of them is C, and the other is D. Because D is not in A, make sure when you put a pointer for D, don't put it inside of A. It's in B, but not in A. So this is called a Venn diagram. And if there's another one, C, how do I draw C? C has F, G, H, right? None of them is in A or B. So you're going to draw a separate circle, C. Put F, G, and H there. So that's completely separate from A and B. Why is Venn diagram useful? A lot of properties about set theory can be described by using Venn diagram very easily, very intuitively, instead of doing a long proof. And you can just use a Venn diagram. So, for example, A union B. So, for example, if I want to do A intersection with B, what would that be? By looking at the graph, A intersection with B, which means the overlapping part. So what is in the overlapping of A and B? C, right? C is the only one. So instead of looking at the original sets, I'm looking at the picture. Okay, that's the intersection. Whatever belongs to in two circles. What about A union B? All of them, right? It's either in here or in there. So you're going to get A, B, C, D. Everything in two circles. So what if I want to do A minus B? A minus B, remember the definition? You delete members in B from A, right? So you're going to delete C. All you have is A and B. Okay, or in other words means what points are in A but not in B? So only A and B. So by using the Venn diagram, you can sometimes make it a little easier. And the problem we proved before, the first example I did in last Wednesday. Take a look at this one again. I proved that the intersection of A and B is a subset of A. Let me copy this down here. When I did this, I used the definition, proved it. Sometimes, especially in applied math, in statistics, they don't really need you to prove this. Okay, the focus of discrete math is we're trying to learn how to write arguments, how to write proofs, write down logical arguments. But a lot of other classes like statistics, you just need to use formulas to do the problems. They don't care about the proof as long as you remember the property. So for those classes, it's easier to use Venn diagram instead of trying to go by the definition. So for example, this property, we proved it by definition. If you draw a graph, it's going to be Venn diagram. It's going to be very easy. So A is the first circle. B is let me use the blue color. That's B. Now, which part is A intersection B? Which part is A, the intersection of A and B?
Very middle, where it's
Yes.
overlapping.
That's right, right here, right? So this part is the intersection of A and B. And take a look at that. The blue shaded area, is that part of A? Is that containing A? Circle A?
Yeah.
Yes, right? It's part of A. So by looking at the graph, this property is very easy, very straightforward. Okay. And similarly, there is another one we have. I didn't prove. I said you can do it similarly. The intersection of A and B, which is the same part, is also part of B, right? It's in A and in B. That is also a property. You can prove by definition, or if you look at the graph, it's very easy. So that's why sometimes, like in the statistics class, we use Venn diagram to describe the properties. Okay, so this is how you do number 9 if they ask you to draw a Venn diagram. Okay. Any other question? About homework or the practice exam? I know that the second exam, like I said, mentioned before, is going to be much harder because there are a lot of proof questions. So I'm going to summarize the proof techniques, which we have learned so far, and you're going to have most of them on the second exam. So on this first exam, we learned a proof called direct proof. That was before the first exam. And if you remember those questions we did before, for example, we proved like this is, for example, prove this is even, right? You can, it's actually, example like this. Prove this is even. This type of question. And prove A over B plus 2A squared over B squared is rational, that type of question. We could prove these questions directly. How do you prove a number is even? Factor of 2 out, right? If you can factor 2 out, well, that's even. If you can't, then how do you show you? Pretty much you can show you. How do you show it's not even? Which means you have to show it's odd. And 2 times the number plus 1. How do you show it's rational? You're going to try to write it as some single fraction, something over something, which you can do by simple algebra. So this is the type of question we did before the first exam. We call this direct proof. Whatever you need. You want to factor out of 2? You can. You want to write this as a single fraction? You can. But there's another type of question. You cannot factor out of 2. For example, let's give you this, m squared plus n. I want you to show this number is even. How? You need to factor out of 2. We cannot factor out of 2, right? Not like on the first exam, the problems I gave you, I want you to show it's even. You can see it. Well, there's a 2 there. You can factor it out directly. So that's why we call it direct proof. But there are also questions like this, n squared plus n. I want you to show this is even. Well, I cannot factor out the 2. Just like your homework question, practice exam, the first problem, it says, want to show this is divisible by 3, is divisible by 3. Which means you have to what? Factor 3 out of there. You need to write it as 3 times the integer. Well, can we factor out 3 from here? Directly? No, you can't. So if it's on the first exam, I want to show something is divisible by 3. I probably will give you something like this: 6n cubed plus 3n squared plus minus 9. And Can we factor out of 3? Yes, right? You can factor out of 3 very quickly, and this will be called direct proof. But questions like this, well, you cannot factor out of 3 anymore. So you are going to, sometimes if you can, direct proof doesn't work, you will try a new technique. It's what we call, James did mention it, do cases. So the first try is, well, can I do cases? So that's the first practice exam question. Proof by cases. Okay, which cases do I have? How many cases do I have to do? It depends, right? If you need to factor out of 2, most likely you do 2 cases, even or odd, right? But if you want to prove it divisible by 3, most likely you have to do 3 cases. Which are 3 cases? Multiple 3, multiple 3 plus 1, multiple 3 plus 2. I do notice in the grading of homework, some students got confused about that. So let's go over that proof by cases again. All the questions they want you to prove always says for any integer n. So do we know what this integer n is? No. So this integer n could be even, could be odd, right? Okay. But you do also, I do want to emphasize this. Even is just a short name for what kind of numbers. When you say a number is even, it means what? This number is divisible by 2. Yes, okay. Odd means what? Divisible by 2, there's another way to say it. Multiple of 2. Right? You can say divisible by 2 or multiple by 2, they're the same thing. So what kind of number is odd? What's the other way to call an odd number?
Multiple of 2 plus 1.
Yes, a multiple of 2 plus 1. Multiple of 2 plus 1. How would you supposed to represent a multiple of 2? How do you write a multiple of 2? Using symbols. 2k. How do you write a multiple of 2 plus 1?
2k plus 1.
Yes. So that's why whenever you see even, you try to factor out of 2. Odd, you got to factor out of 2 and a plus 1. Okay. So when you do cases, well, one thing you could do is case 1, 2k. Case 2, 2k plus 1. But you need to understand how to get 2k and 2k plus 1 because it's even or odd. But any integer, it's either even or odd. If it's not even, it has to be odd. Or in the other words, if it's a multiple of 2, or not a multiple of 2. If it's not a multiple of 2, it has to be a multiple of 2 plus 1. That's why we got these 2 cases. But sometimes when you do even or odd, it doesn't work. You may have to do 3 cases. So when I draw this picture for you before. Okay, if all the integers are here, say 0, 1, 2, 3, 4, and 5, and negative, even negatives, negative 1, negative 2, I could do a division like what? Put all the evens together, all the odds together, right? So I could do this. So all of these are 2k, like 0, 2, 4, negative 2, all of these. Or I could do 2k plus 1, all the odd ones, 1, 3, 5, all the odd ones here. So that's what. And that will include every single integer, correct? But sometimes maybe even or it doesn't work. Like your whole first practice exam question. They want you to factor out of 3. If you do odd, you're not going to be able to factor out of 3. You will be able to factor out of 2 or 4, but not 3. So maybe I could divide them into 3 categories. Because any integer, if possible, if this integer is a multiple of 3, how do you describe a multiple of 3? Like those integers, 3, like 0, 3, 6, 9, 12, 15, all of these numbers, they are
3K.
multiple 3k, yes. So if they are multiple of 3, I can just use 3k to represent all these numbers. But there are also numbers that are not 3k, they're not multiple of 3. For example, 1, 4, 7, 10, 13, 16. All these numbers, they are not multiple of 3. But they are multiple of 3 plus 1, right? So if they're multiple of 3 plus 1, I can use what symbol? 3k plus 1. 3k means a multiple of 3, plus 1 means plus 1. But what about numbers like 2, 5, 8, 11, and 14, and 17. What about these numbers? Are they multiples of 3? No. Are they multiples of 3 plus 1? No. For example, 5. How do you write it? It's 3 plus 2. What about 8? It's 6 plus 2. What about 17? It's 15 plus 2. Look, all of them are what? A multiple of 3 plus 2, right? So that's why we can use 3k plus 2 to represent all these numbers. And look at all of them together. Are we missing any integer? No. Look, 0 is here, 1 is here, 2 is here, 3 is here, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We include all the integers. You see that? Okay. And notice that they want us to prove for any integer. And if I do these 3 cases, I proved every integer. I'm able to factor out 3. So it depends on how many cases do we have to do. It depends on what you need to factor out. If you need to factor out 2, most likely 2k plus 1 will work. Case 1, case 2. But if you need to factor out 3, most likely you have to do 3 cases. Case 1. I'm sorry, I'm not saying 100%, but most likely you got to do 3 cases. Like I said, I probably won't ask you to do 4 cases, but if I do want to do 4 cases, which 4 cases will be following this pattern here? Which 4 cases will it be? 4k, 4k plus 1, 4k plus 2, and 4k plus 3. It's very easy to divide all the integers into different cases. If you want 2 cases, divide all the integers by 2. Any number divided by 2, you're going to have either remainder 0 or remainder 1. If the remainder is 0, these are multiples of 2. If the remainder is 1, these are multiples of 2 plus 1. How do you get 3 categories? How are 3 cases? Divide any integer by 3. You may get a remainder 0, remainder 1, or remainder 2. How do you get 4 cases? Divide every integer by 4. You can get remainder 0, or remainder 1, or remainder 2, or remainder 3. Okay. So this is based on sort of like a very easy property. Any number, any integer divided by, say, 5, how many remainders will you get? Take any integer divided by 5. How many different remainders will you get? 5, right? You could get a remainder 0, or 1, or 2, or 3, or 4, right? So if you want to do 5 cases, divide by 5. If you want to do 2 cases, divide by 2. So that's how you get different cases. So that's first problem on the practice exam. I cannot, when I look at n cubed plus 2n, I cannot factor out of 3. I realize, okay, let's try cases. And how many cases should I do? 2 cases probably won't work. So I try 3 cases, okay? Now, that's the proof technique. First one will be tested on is called proof by cases. Now, look at the second question. They want you to show square root of A is irrational. So you are given A is irrational. How do you prove square root of A is irrational? Will cases work here? Probably not, because you are A right here. First of all, it's not an integer. It's a real number. You cannot really do the cases here. So you're not going to be able, usually cases, when you do those cases, you can factor out something, but here we're not trying to factor out anything. Can we do direct proof? That's what we did on the first exam. But again, I gave you a tip in class. I said, if you know R is rational, and trying to prove 3r squared minus half of r plus 7 over 3 is rational, you can use direct proof. Because you're trying to prove something is rational, which means you're trying to prove something is a fraction. All you have to do is to write this as a single fraction. But how do you prove something is irrational? Which means you need to show this is not a fraction. How do we show something is not a fraction? You can show something is a fraction by just showing us, okay, look, I can show you this is something divided by something. An integer divided by integer, it's a fraction. But you cannot show somebody this is not a fraction. So direct proof won't work proof by cases won't work. You're going to use what we call indirect proof. That's the second proof technique we use a lot in math. Okay. How do we do indirect proof? What was the format? You always start with what? What's the first thing you always say? Suppose the opposite. We don't really call opposite. We say what? The negation, right? So we call it. So suppose the negation is true, and you are going to get a contradiction. I do notice in the proof writing, and a lot of times it's not very clear what the contradiction is. So you do need to specify, say, okay, this is a contradiction. If you can get a contradiction, then original statement is proved. Okay, so this is the second type of question. Number 2, number 3, and number 4 are all indirect proofs. So on the practice exam, you're going to have 3. So number 2, number 3, number 4. All these questions are indirect proofs. The first one is proof by cases. Number 5, number 6, what type of question are these? Number 5, 6, 7. What kind of proof question are these? Mathematical induction, that's right. And also we have been working on that recently. So how do you do mathematical induction? You always start with the basis, whatever you plug it in, and the inductive step. How do we do inductive step? I notice, always assume the formula or the property is true for K, and prove is true for K, and prove the property is true for K plus 1. For n equal to K, and prove the property is true for n equal to K plus 1. And which is what some of the students, they use P of K. So what's P of K? P is the first letter of property, K is K. So sometimes we say, assume P of K is true and prove P of K plus 1 is true. I mean, if you like those symbols, you can, but you don't really have to use those symbols. So that's, P of K means the property is true for n equal to K. So that's the second 5, 6, 7, each of them represents a certain type of mathematical induction. So that is a formula, something equals something. Second type is divisibility. Something is divisible by something. The third one is the inequality. There are 3 types of mathematical problems mathematical induction can be applied to do. Okay, and so these are the main proof. And the last one is also proof, the set theory, which I just went over with you. That is basically direct proof, and you just have to use the definition of the union, section, and subset. I think those are the main parts. Okay, well, I guess I don't really have much time left, so if you still have trouble doing any of those questions, send me an email. And on Wednesday, I'm going to go over this. Make sure you turn it in either today, latest will be tomorrow. Okay, so make sure you turn it on time.
You said that don't do, which one's not to do? You said, was it 13 through 15?
Yes. That's
Okay,
right.
I just wanted to make sure.
Okay. All right, that's all for today.
Your meeting has ended.